And today I am going to present here the kinematic control, which is a new feature available with S7-1500T CPU. So we'll cover in this session the basics of kinematics, then what we have in TI portal for the kinematics control. And with the help of available resources in TI portal, our headquarter team developed some standard library, some standard application to ease a commissioning job easy for a commissioning engineer. So yeah, this is my agenda for today's session, and we'll see the demo, the standard applications also. So let's begin where we can apply the kinematics. So these are the PA production machine application branches. Let's say plastics, packaging, metal forming, glass, food, renewable, printing, and textile. All the industry now demanding for a high production rate and high productivity. That's why we need a complete automation over there for all the handling kind of application. You can say, for example, let's say plastic. In plastic, there is an injection molding machine. We need to take out the product, final product from the machine. So we need over there the handling solution. We call as the Cartesian Portal Kinematics, and this is the solution for plastic industry. Similarly, for packaging, we have pelletizing, case packaging, and pick and place applications. And similarly for metal forming and glass and the other industry also, we are providing the solution, and we called as the branch of handling branch, our PMA. So this all are the industry now demanding the handling solutions. So now we see what is the basics of kinematics actually. So in kinematics, let's say if you want to place some product from some pick position to place position in a free space, then you need interpolations. You can do these things by positioning, simple positioning and things, but it takes time, or the motion will be maybe more jerky. So the path definition is required. And when you move something in a free space means in XYZ coordinate system, then we require the interpolations. It is above from positioning and the synchronization. So for that, the system which we used for that particular application, we called as a kinematic system. And here you can see one of the example of kinematics we called as 2D delta picker. It is called 2D because the two axes are responsible for my tool center point movement. Tool center point nothing but maybe it will be the gripper, or it will be some tool to finish any application job. Let's say the CNC jobs and all. So we can call as a TCP point, and the motion of the TCP point depends on these two axes, which is coupled with the kinematic system. So this is the basics of the kinematics. And why it is required for means it is required when you move something in free space and you don't want to achieve this task by use of simple positioning and all. So the interpolation is needed. That's why we introduce the kinematics functions. This is the basics of kinematics. Then how it will work with the free space and the drives. So in the kinematics, there is two types of transformation. One is the inverse transformation, one is forward transformation. What it means? It has some equation algorithm within the function blocks, which will convert, let's say you have one kinematic system, let's say 2D delta picker. So for that, you need to define some geometrical data of that particular kinematics. Here, if you have this particular kinematics, then you need to provide this geometrical data, the length and the other things related to the particular kinematics to the technology object or a function block. And then you need to define a path. Path means you want to move something in free space from point A to point B, which called as a path. You need to define that path, and you need to do the path planning also for the motion in free space for the TCP. And based on that two things and the velocity of path, the inverse transformation will calculate the XYZ coordinates into the position set point for the drive. Because when you define path in free space, it is defined in terms of XYZ only, okay, for the operator point of view. But for the drive, we require to convert it into the position set point for the drive. And this three motor, let's say if it is XYZ direction, then there is a three motor involved in it. So for three motors, we require the position set point for all the three motors. And these three motors will coupled with the kinematic system, and it will allow to TCP to travel the defined path. So this is inverse transformation. Then the forward transformation for a closed loop system, we always try to monitor the actual position of the TCP so that our system will be run in a closed loop system. So we read the actual position of our drives, and then with the help of forward transformation, it is nothing but there is a equation behind it and some algorithm, and based on that it will calculate the actual position of the path, the x, y, z coordinates, and the A is the for rotary axis. Suppose there are some kinematic which having some rotary axis also. So x, y, z and the rotary motion there. That's why it can interpolate up to 4 axes, x, y, z and rotary axis. So this is the actual flow of kinematics systems. And this is the basic of kinematics. Then how to do path planning and why it is required. So suppose if you have some pick and place application in which you want to pick some product from P0 position and place at P4 position, it may chance there will be some obstacle between P0 and P4. That's why you need to do one path planning. You cannot move like linearly from P0 to P4. So for that we require the path planning, and in path planning we define different segments. Let's say P0 to P1 one linear segment, then P1 to P2 another linear segment, and here I require some circular mode because I need to avoid, let's say, some jerk up and things during the motion. So we'll add another segment with a circle, and then again P3 to P4 one linear segment. So this is the way. First you need to do the path planning for your pick and place application, and then this path planning can be used in our technology object, and based on the geometry of the particular kinematics it will calculate the set points for the kinematics motor. So this is path planning for kinematics. Then till now we have covered that it is the basics of kinematics and all. Now what we have in TI portal new to do this job. So for that we have a technology object in kinematics which called as a TO kinematics or technology object kinematics, which is new added in the TI portal technology objects. And what is the feature of it? Means I explained you the forward transformation or inverse transformation for calculating the actual position of coordinate system or actual position of the drive or generate a set point for the drives. So this particular technology object already having 26 predefined kinematics, means it has 26 equations for inverse and forward transformation. So you don't need to write a code separately in a PLC program for a transformation for a predefined 26 standard kinematics. This technology object interpolate up to 4 axes only. That's why we call this 4D path interpolations. Means it cannot fulfill the 6D interpolations. Means have you seen the robots, KUKA robots, the six axis robot? So with the help of TCP, we cannot interpolate. We can do only 4D, and D means 4 drives, 4 directions, maybe X, Y, Z, and one is rotary direction. Then we can define the user defined transformation. So for the user defined, maybe you in some cases maybe we have some specific kinematic system which is not in our standard list. Then in that case we require to define the equation or algorithm for inverse and forward transformation, and with the help of user defined transformation we can execute our task. So yeah, it allows user defined kinematics also to be configured within the technology object. Then in kinematic system, the coordinate system is also very important. So we have coordinate system for kinematics, we have coordinate system for tool on the kinematics, and the object. For the object also we have coordinate system. Object is nothing but suppose if you have some application where pick and place and your object on the conveyor, and in the conveyor maybe object is 3 places and you need to put something in first place, second place and third place, then you need to define OCS frame for this particular object, and object coordinate system will take care of the offset of this particular cavities, and it will fulfill your application requirement without every time adding and write some extra code for adding offset in the motion. So it will take care by the technology object. So in that kind of application we require to define the coordinate systems and frames for the kinematic system. Then on a commissioning point of view, we have a great feature which is available with the technology object of kinematics. One is the control panel. So initial commissioning completely you can do with the help of kinematic control panel without writing a single code. You can test all the things with the help of this control panel. Then the kinematic traces. So there is a one kinematic trace feature available with the TO kinematics, and it is a 3D visualization trace. So you can monitor your motion and you can trace your path within the simulation mode only. And yeah, you can test all the motion, path, and things in the simulation only. So it saves your time, means you don't need to wait for a machine readiness. You can test all your code or program only in simulation with the help of kinematic trace. You can monitor it. Then the diagnosis screen separately available as like a servo drive. We have diagnosis screen, similar diagnosis screen available for the technology object. So this is the left side, which is completely part of configuration and the commissioning. Then the user program side, we have PLC open commands for kinematic control. So linear circular movements required, then you can use the PLC open commands and write your code for a kinematic motion. The safety point of view in kinematics, the safety is important. That's why there is a zone definition and zone management systems are available. So there are different zones available, block zone, work zone, and other signal zones are available. So you can define zones and you can restrict your kinematic system to collide in or to avoid any accident in your motion. So whenever the zone collision happen, the kinematic will stop. So this zone management is very useful as per the safety concerns. So this is the technology object, and these all are the features. Now, what is the 26 standard kinematic? So we'll see in next slide. So these all are the 26 predefined kinematics are available in TI portal. You can see the Cartesian portal. In Cartesian portal, there is a different combinations. Let's say 2D with orientation, 3D with orientation. 3D means 3 axis, X, Y, Z, and orientation axis. Orientation axis on the X or Y or Z anywhere, but you can only interpolate up to 4 axes, not more than 4. Similarly, articulated arm, tripod, cylindrical robot, roller picker, delta picker, and SCARA robot. So these all predefined 26 kinematics are available in TI portal, and technology object of kinematics supports all the 26 kinematics. For that, you don't need to write any algorithm or equations. You only control this kinematics with the help of user program. And the transformation inside the kinematics will be handled by technology object, because for all the 26 predefined kinematics, the equations of inverse and forward transformation is already available. So these all are the 26 kinematics. Yeah. And the user defined kinematics also possible, as I mentioned earlier. You can define if you have some specific requirement from a specific OEM and you want to create some user defined kinematics over there, so it is possible, but only the things you need to write a user transformation over there. The user transformation inverse and forward transformations equations that it can convert the coordinate system to the set point for the axis, and actual position from the axis it will convert the coordinate system. Now, the technology object kinematics principle. So, as like drive, we have to create the same philosophy for a technology object of kinematics. First, we require, let's say, if I am having 4D kinematics, we need to create 4 drives in our TI portal software. Then, for every drive, we need to create a technology object, the axis. You can see all the axes are positioning axis. Then there is a group object we called as a technology object of kinematics, and this group object will configure based on all these 4 drives, so that this is the communication between the group object and all the drives. So set point will be generated from the TO kinematics for all the individual axes and based on the transformation. Then to control this group object or technology object of kinematics, we require some user program. So for that, we need to write a user program with the help of PLC open commands. this is the way how to program a kinematic system in TI Portal software. PLC open commands which I have mentioned. So this all are the PLC open commands are available in TI Portal. MC move linear, absolute or relative. Similarly for circular motion, absolute or relative commands are available. You can stop your kinematics in between, or it means with the help of interrupt command, and you can continue it. So when you travel, let's say from point A to point B, then in between, if you want to inspect something with the help of some camera system, so that you can interrupt the kinematics motion and you can inspect over there something, and again you can continue after the signal is okay, then you can continue your path. So this all are the command will be helpful for write a code, user code. And the control panel of kinematics, this is the control panel of kinematics. So you can do the commissioning, initial commissioning with the help of the control panel. Drive enable, jog of kinematics and jog to target position. So everything is possible. To homing the individual axis of kinematics, you can home it. So this is the control panel of kinematics, similar which we have for axis. The 3D trace. So this is the 3D kinematic trace available, and you can check your path or test your path in simulation mode. And after it is okay, then you can test your actual code or program on actual machine. That is very helpful for initial commissioning and testing in offline mode only. So this all are the features which is available on kinematics, and yeah, but this all the resources which is available in TI portal. But with the help of all these resources, let's say PLC open commands and all, our headquarter team develops some standard applications library which is very helpful to reduce the commissioning time and ease of working on a kinematic system. So we'll discuss one by one libraries so that you can, and all this library you can get from the COS website. The first is the kinematic control library. So you can see here the library is means in this particular library there is one block MC move path, and it is developed with the help of all the PLC open commands. So suppose if you want to write the first code of kinematic system, then if you have let's say 10 to 15 segments in your machine, then you need to call this absolute command or circular command multiple times, and it will increase your code length also, and it takes a lot of time to write a code. So now with the help of this library, you only define a path data. We'll see what is the path data. Path data you need to define means all the segments, and you define here axis group, the DO kinematics, and all the execute stop interrupt command which is available for the group control of the kinematics. It is also available as an input, and if you want to sequentially run all the commands, it is possible with the help of this function block. So in overall, this is the only block which you need to use for your path motion, and you need to define only the path data, the other configuration parameter, and these all are the control parameter of the kinematics. The execute command is stop, interrupt, and reset. So it reduces our programming, and it is very managed way to program a kinematic system, because within the block there is a buffer system which can handle all the commands sequentially within it. So you don't need to worry about the delay or any cycle time issues and all for command motion commands. It can be handled by this particular block only. What is the path data now? So path data have a multiple commands. Here is only showing the 10 commands, but you can extend the array length accordingly your application requirement, and yeah, you can configure multiple commands one by one. Then this command will pass to the move path as a path data, and then move path execution, you will get your path profile and your path will be run. Then this is the complete parameter list for a single command. Similarly, you will get for all the commands. And in the command list, you need to define the coordinates of the first point. Let's say I have some pick and place application which I shown you during the time of path planning. So for the P0 point, I need to define X, Y, Z coordinates, then P1, then P2, then P3. So I need to define every command within the path data in command list, and the dynamics, let's say for a particular segments, and the other parameters. If there is a circular mode motion, then you need to define the circle mode and the other parameter. So this detailing you will get in the manual of the library, how to define a different parameter. But the basic parameter is the Cartesian positions and the dynamics. You can define the dynamics, and after that your path will be executed based on all the commands. So you can see here only you need to define a command list. You don't need to write or call all the PLC open commands. Let's say for MC, if there is a 10 command, then you need to define 10 times MC move linear absolute command. So this all things can be taken care by this particular MC move path FB. Then another library which is available, the standard template for a HMI point of view, because HMI also uh, takes a lot of time to develop. So the basic HMI standard templates available for the kinematic control. So you can see all the functionality related to the jog, related to the other configuration of the kinematic system. So you will take this library and you can import in your project, and the basic things you don't need to develop. You only need to develop other machine parameter and things. So it is very easy and plug and play solution for kinematic control. And what are the screens are available so that the jog kinematics can be possible with this library. Then the zone monitoring. So the different zones you can define and active and deactive your zones within the kinematic system. Then you can define the coordinate systems. It is all part of technology object, but with the help of this library, you can get all the access on the HMI only. So you don't need to write a separate code for that. It is readily available on CEO's website. So you can just download and import in your program and just execute your project. And another library application example available, the Gcode to move path. So suppose if you have something, let's say Siemens engineered something graph and kind of things. So you need to convert with the help of some third-party KM software in a Gcode format. Okay, because this library can read only Gcode, and this KM software will convert .svg file in Gcode. And then there is one tool available from the handling team. It is the Excel macros, and with the help of that, you can generate the path data. And this path data will pass to the MC move path FB, which I shown in the library section, the first section. And then you can execute your MC move path and your path will be run with the help of kinematic system. So this is also application example readily available on CEO's website. So if you have kind of application, contour application, you can just directly convert the Gcode file to the move path or path data. Then another one more application available, which we call as a L kinematic language package. It is available for Gcode only. So maybe it is not fulfill all the Gcode commands requirement, but majorly it take almost cover all the commands which is fulfilled by the CNC controller also. So if you have some basic Gcode application, so you can go with this particular application, and it is it will the basic behind it all similarly same. Let's say it will pass the Gcode into the path data, and then path data pass to the MC move path, and your path will be run. So this application also very useful and readily available on CEO's website, and the HMI also available for that. So You don't need to write a single code in TI portal software. Everything can be controlled from the HMI only. So there is a MMC slots available, USB available. So you can put your .nc files into the MMC or a USB you can access, and then this file will be parsed with the help of this parse command. And after parser, you will get the edit in editor. You will get all the commands, and if you want to edit or delete any command, it is possible with the help of the HMI. And then you can start your path, the kinematic path. So this is the example project HMI screen for Gcode. It is available on COS, and if you have some kind of application, you can go with it with this application. So here is a program manager, and here is a textual editor for the Gcode application. You can see the Gcode commands. Generally, it is handled by the numeric controllers, but for the basic application, with the help of S7-1500T, you can execute your application or machine. But it will not 1:1 comparison with numeric, because in numeric you will get a more flexibility and more commands, but it is only just for basic applications. In one more application, Simatic Kinematics Operate, it is also a plug and play solution completely. Means you don't need to write a single code. Even the IO definition also can be possible from the HMI only. IO definition, IO naming, and all those things. So we call it as Simatic Kinematics Operate, and it is also available on COS on this entry. It is easy for programming. You can configure your, you can commissioning your program, means you can teach your path, then you can commissioning your program, and you can monitor your program from the HMI only. So you don't need to write a single code for that. So very helpful for means I can say for small applications. Let's say for injection molding machine, for a takeout, we call as a takeout. Means in injection molding machine, there is a product we need to take out from the machine. So there is a robot we call as the Cartesian Portal, because it has a 3-axis robot. And yeah, for that we need interpolation also. But suppose if there is a requirement only the sequence commands and things, then if you don't want to go with the interpolation or with the TO kinematics, so this application fulfill your requirement with the help of only the 1500 PLC. So with 1500 and 1500T, both with both the things it is supported. But if you have some kind of requirement only that you have only 1500 PLC and you want to do same kinematic kind of operations, okay, so you can go with this application. In that application, you can commissioning your machine, means you can define the path, complete path, and this path parameters can be taught, and you can copy in the editor program, and you can use it in the editor. In editor also you can have a different command, wait command, label, loop commands, and the positioning commands available. So you can configure your complete sequence of code from the HMI in the editor, and then you can control, or maybe the operation, machine operation you can do with the help of the HMI, the start, stop, and you can reduce dynamics and all these things can be possible from the HMI only. And you can define the IOs and all. Means if you go with in the detailed in that particular application, you will get inside of that all the things you can define from the HMI only. So here I'm just giving some glimpse of this application, but yeah, if you go in the detailed view, you will get more insight and more things that can be possible with that application. Differences to TO kinematics. So there is a difference of with the TO, means earlier I explained the TO kinematics. So TO kinematics, our high-end solutions, means it fulfills all the requirements. But with the Simatic kinematics, if we have Simatic 1500, then we'll at some side, some level we can fulfill the requirement of kinematics. So that's why I have mentioned this application here. But yeah, in the full scope it is not helpful. Then you need to go only with the TIA kinematics or TCPU. So it supports only the Cartesian portal, but here you will get the 26 predefined kinematics and user defined kinematics also. Then supported axis 6 here, but it is not interpolation, but it support up to 6 axis, and it can interpolate up to 4 axis. Ready to run HMI project. So yeah, available with Simatic kinematics, but with that only the some basic kinematic function you can do with the help of HMI. The ready HMI available, I will show in the demo. And then other point-to-point movements, yeah, both are support. Both things are support in both the controller. The linear movement, circular movement, dynamic adoption, and zone management. It is not possible in Simatic kinematic operate. In case of zone, only the cuboid block zones are available, but in the TO kinematics, you will get all the options, which I already explained to you. So for basic applications, you can go with Simatic kinematics operate also. So this is the theory and the application which we have, and other also application we have. But at that time, it is the basic application which we have, and just I want to share with you. That's why I'm covered this major applications. But yeah, apart from that, we also have some other application. We'll get on the COS on handling means when you access the handling schematic handling page, then you will get other application also over there, the high-end applications. But it is the basic requirement for any commissioning of TO kinematics. So now I will switch to the demo. I will show you how to configure the technology object in TI portal and how to monitor trace, kinematic trace. So this is the standard libraries and program available on COS. You can go at that entry and you can see the Simatic S7-1500T kinematic controller. This is the entry ID, and here you will get the documentation of the library and example project. You can download, and it is means direct plug and play solution, and you can test it. Means you don't need to do any editing and anything over there. You can import in your program also. Means if you want to use something from this example project, you can directly use. So for a technology object, uh, first we required a 4-axis, which I mentioned that the principle of technology, principle of kinematic control. So for that, first we require the drives. But here I am going to show you the simulation in simulation mode. That's why I have not configured the actual drives. I have configured only axis, the virtual axis. So you need a 4-axis, virtual axis, position axis. So how to add position axis, maybe you know, but still I will show you. So add new technology object. Here you will get all the available technology object in TI portal. So for axis, we need to configure TO positioning axis. And for the kinematics, we require TO kinematics. So this is the my roller picker. You can see here the roller picker. This is the group of axes, and we call it as a technology object of kinematics. Okay. So after adding 4 axes, you need to add a technology object for the kinematics. And for the axis configuration, it is basic things we need to configure initially: the axis type and the parameters. So right now I am using the virtual axis only because I am not having a physical drive. And then the axis type, let's say linear or rotary. And then other parameter of the drive, you need to configure the drives. Here you need to connect your drives, Ethernet drives, let's say S210 or V90. Then data exchange with the drive will happen with the help of standard Telegram 105. The Telegram is nothing but the message frame which is required for data exchange between controller and drive. Similarly, you need to define mechanics for particular axis. So in the rotary axis, there is no required to define any the circumference and all. If you have linear axis, then you will get the entry here, the gearbox or gearbox and those 1 mm per revolution entry. So you need to enter the mechanics part. The dynamics part also you need to define the default dynamics, velocity, acceleration, deceleration. So this is the basic configuration of the axis. But here my more major focus today on kinematics. So for the kinematic configuration, what you need to define in the configuration wizard, we'll see. So first is the I already explained it. This technology object supports 26 predefined kinematics. Here is the list of all the kinematics which is available standard. According to your application requirement, you can select. Means sometimes maybe you will get the Cartesian Portal 3D or Cartesian Portal only 3D, not with orientation. So you can choose. So in my case, right now in this demo, I am choosing that roller picker 3D with orientation. Then there is an interconnection of this particular kinematics we need to define. So we already added 4 axes, 4 positioning axis, because it is required because we selected roller picker 3D with orientation and 3 axes for 3 direction X, Y, Z and the orientation axis for this particular gripper kind of maybe anything, it is anything gripper or some tool. So for that we required 4th axis. And then it will allow you to configure that this is one my first axis, then second, third, and fourth. So this allows the 4 axis configuration. So as I said, TO kinematic is a group of axes. So all the 4 axes are configured within the kinematics. Then the geometry of the kinematics we need to define, because during the time of path planning I explained you the geometry and the path data we require to generate a set point for individual axis. So this set point will be generated by the TO kinematics. So this is the basic, just let's say the radius for the particular pulley, and these things are we need to define. So as per the kinematic systems physically you have on your machine, you can get this data and you can put this data into the technology object. Then for the trace monitoring, you need to define the coordinates, let's say. So you can configure accordingly to your range of motion. So it is helpful for kinematic trace visualization. Then convey tracking, it is also one solution which is available now with TI version 17, TI version 617, yeah, the convey tracking. So now this time it is not required to do anything with that, but yeah, it is also new features available with version 17. Then the dynamics for the kinematics. So it is the maximum velocity SLD cell and it is the default. So when you move your kinematics with the default parameter, then it will take the velocity SLD cell from here. Okay. And also you can write in the path data also, you can write all the dynamics parameter. Then coordinate system, if you need to define, if you require to define coordinate system, you can define all the coordinate system. So it is take care of actually the offset, means your main coordinate system is what coordinate system and your kinematics suppose somewhere here. So the offset in X, Y, Z direction automatically every time taken care by this technology object with respect to the kinematic distance from the what coordinate system. Maybe sometimes you have multiple kinematic system. So in that way, it is very helpful because every time you don't need to add. So once your kinematics move in some direction, every time you don't need to add the offset with the set point. It is taken care by the kinematics once you define the frame of the coordinate system. Similarly, for object, also the coordinate systems are available. Suppose your kinematics is here and your object is here, means the conveyor, let's say. On conveyor, there is a 3 cavity. So this offset in is this direction, let's say in the X direction, 50 mm offset for each cavity. That 50 mm will be added automatically with the help of this object coordinate system frame. So every time you don't need to add in the x direction set point the 50 mm, because first time you go here, but next time the set point will be same, but it is taken care by only the OCS that I need to move 50 mm plus. Then again move 50 mm plus. So this OCS frame helpful in that case. Similarly for tools or flange, the, the coordinate systems available, the distance, the offset between tool and flange can be defined with the help of this coordinate system. The zones, you can configure zones as per the requirement. There are different zones are available and you can configure zones. So two types of zone, workspace zone and kinematics. So for kinematics, zones available and for workspace. And in the zones, you can define the different zones. You can see the work zone, block zone, and signal zone. Work zone means you allow to kinematics move in particular zone. Block zone means you don't need to allow kinematics to run in that particular zone. Means whenever the kinematics by mistake go in that particular zone, the kinematic should stop and generate alarm. The signal zone. In signal zone, suppose if you are moving your TCP in free space and at some particular section you need some signals, but so it will provide you a signal, but it will not show the alarms. It will just give you signals. So suppose if I'm taking example of I need some triggering for the some camera system to detect something. So in the particular zone, I will generate one signal and I will provide this signal my camera to trigger the pictures for a particular position. So in that way, I can configure my zones in kinematics. And for the zones, you can define a different geometry. So you can see here the cuboid, cylindrical, and spherical geometry available. In this geometry size, you can configure the X, Y, and Z direction. This is the zone configuration, which is also possible in the kinematics. And for safety point of view, the block zone is very useful. Sometimes our kinematics system may be the chance to collide with the system because there is more obstacle between pick and place positions and all. Then in that case, the zone monitoring is continuously needed during the motion of kinematics. Then this is the commissioning control panel for the commissioning of the kinematic system. The basic commissioning you can do with the help of this control panel. So I am already activated that PLC Sim Advanced. You can just control your kinematics with the help of this control panel. You can see here the X direction motion. Also define job to target position. So you need to define target position. This is my target position. Here you can define the target position. Let's say I can change. You can jog towards the target position to your X compare, and it will move as per the interpolation profile. So this basic commissioning can be possible with the help of control panel. Then in this particular example project, we have a dedicated HMI which is available. So for the contour application, here you can see in the information also when you run this runtime, you can see here first enable the demo FB, second edit the program, then editor open in the new window. So first enable, let's say the demo, then open the editor. So in the editor, you will get all the command list, and if you want some insert some commands or delete some commands, you can do with the help of these commands, and you can configure the command with the help of this wizard. Here you can define the xyz coordinates, dynamics for that particular command you can define. There are other features available. Let's say flex nothing, but if you want to actuate some solenoid walls something, during the time of motion. So you can use this flag option. And the flag also there are different conditions. Set before means set before and reset after means this flag will be set before starting particular segment, and that is and if you select the reset, it will reset automatically after the completion of this particular segment. So different possibility available to configure the flags. You can do as per the requirement or as per the application requirement. These all are the configuration commands available. You can define tool as I mentioned in the configuration of technology object coordinate system. You can define zone or active zone or deactive zones from the HMI only. Select the cube by cylindrical sphere. Means anything you can means want to do configure. You don't need to go every time in TI portal software in the configuration of the most kinematics. You can do with the help of HMI, because in this example project everything available on the HMI. So yeah, this is the example project. Now we'll show how to do, how to run, and how to. So in this example project, there are different scenario available for contour for pick and press application, Gcode to move path and convert, track and convert. I will show here only contour and Gcode to move path because there is a limitation of time also. So let's say see first the contour. So for the contour, and also you will have in this example project, you will have the wash table to run all the scenario. But on the HMI only we have contour option. But for testing other, you can go with this wash table and you can test your program. You open the kinematic trace. So you can see here the 3D visualization of the kinematics. I will start the trace. Whatever your path, it will be here. You can see after enabling the kinematics. Now I will execute. The start path means the execute command to particular move path MP. So you can see here that your program is execution, and it will it will draw it whatever you require, whatever profile you require, you will get here. You can see. So this is the 3D trace, which is very helpful for monitoring our program in offline in simulation mode only. You don't need to go in physical machine and test all the things. You can test in simulation mode and you can visualize to your path in the motions and all those things with the help of this visualization feature of 3D trace. So this is one example for contour, which is I ran through the HMI. Second demo I will show for Gcode to move path, how to generate a DB for that, and then how to import in our program I will show you. So let's say you have some NC file, let's say here the Siemens.nc file I have. You can see all the G code are there, and there are thousands of lines available for that particular application. So every command I need to enter in my command list, it is very difficult. So with this application G code to move path, there is a wizard which I show macros of Excel. It will automatically generate a DB for that particular .nc file. So from this application, you can just select your NC file where it is. So in my case, Here I need to select cml.lc, then I need to click on generate. Okay. Okay, so data block source was generated successfully, and in the same folder you will in the same folder you will get that siemens.db, and then you just need to go in your TI portal software. In TI portal, there is a in program block there is a external source file folder where you need to import it. Add new external file. It will ask where is your external file. You just add it and then generate the DB from this file. Generate block from source. So it will automatically generate DB, and this DB will be available here. Let's say so, and is in that particular DB you will get complete your path data. The commands which I will shown you in the library of Kinematic Control. So these all are the commands automatically configured here. So you can see here the multiple commands, the thousands of commands can be configured automatically. And in that command, you need to pass all the parameter, nothing. Let's say either the Z position only, and the command parameter, let's say path dynamics, automatically assigned. And for just for testing, I will show you with the help of this watch table. So first I need to enable my path demo as I did in this application, enable the path and open editor. So here I need to, because this GUI not available on HMI, so I need to do manually here in the watch table. So I will just already configure all the things which what is required. You can see here, and then I will execute my path. But before that, I will start the trace and execute the path. So you will see the profile which we see in Siemens Ingenuity for life will be completely raw here. So this is the application for Gcode to move path. And if you have some similar kind of application, similar kind of profile or contour profile in .nc format, so you can convert it into the path data and pass that particular path data to the move path, and then after you will get your motion accordingly to the requirement. It is possible with the help of TCPU and with the help of TO Kinematics.